Okay, so just found the determinant of this matrix up here using this first row A, B, C, and we can see the coefficients are here for that first row A, B, and C. Now, I didn't go into much details about this in that example, but this method is called using minors and cofactors. And a minor is really this little determinant, these 2 by 2 determinants that we have. So a minor, right, if I take this matrix, for the first row, first column would be me deleting the first row, first column and taking what's left. So when I go through this one, I'll label the minors. We don't really have to worry too much about the definitions, but in the future, you may hear someone use these terms. Cofactors are what you get when you add this positive or negative one in front. And there is a formula for the cofactors, but it always follows a pattern, kind of this honeycomb pattern for what's positive and what's negative. And it looks like this. So this is why in that formula above, and the book just gives this formula, this second entry, B here, is negative because that's in a negative position in our little positive negative chart. So the cofactor would just be actually evaluating one of these minors, finding the determinant, and then putting the proper sign on there, so leaving out the row numbers. But again, don't really worry about the minor cofactor terms. We just need to worry about how to find the determinant of a matrix. So for this example, since I did it already up top using A, B, and C, I want to use a different row. And the book doesn't give any other formulas for this. They just say, here you go, do that. And if you do that every time, you'll be fine. You'll get the right determinant. But for a lot of matrices, there's an easier way. Because, for example, this last row, if I use this guy, well, I have a 0 there. So instead of multiplying by negative 3, 2, and 4, I can multiply by a 0 and cancel out a full term. So I'm going to write out first these 3 terms. I have a negative 1, a 4, and a 0. So that's from that last row. Next thing I'm going to do is think about the signs for the row. So the first and the last are the same. So negative 1 stays the same sign it has. 0 doesn't really matter, but stays the same sign it has. 4, though, we need to take the opposite. So we're going to be subtracting this term. Right now, everything else stays the same from what we did up top. So to get this minor here, the negative 1 is in the third row and the first column. So I would be really looking for this minor. We would call it minor 3, 1, third row, first column. And I get that by canceling out the third row and the first column and taking the determinant of what's left. So 2, 4, negative 1, 2. All right, then we're going to go into the next one. So 4 is down here. That's in the third row, so I'm going to cross it out. And the second column, so I'm going to cross that out. And the numbers that are left, negative 3, 4, 1, and 2 are my minor for that one. All right, for the last one, we really wouldn't have to worry about it because we're multiplying 0 times whatever is in the minor. But just to get the hang of finding it, we would cross out the row that the 0 is in and the column that the 0 is in, and we'd be left with negative 3, 2, 1, negative 1. But again, 0 times that guy cancels it out anyway. So I'm going to multiply the rest, right, finding these determinants with diagonal. So 2 times 2 is 4 minus negative 4, since we got negative 1 times 4. And then negative 3 times 2 minus 4 times 1. Hoping this works out to be a positive 32, since that's what we got there. And I think we're good. We'll get negative 8 plus 40 equals 32, which is my determinant. So another method, I want you guys to try out the next one, finding the determinant. And as always, let me know any questions.